Hello all, welcome to today's webinar. Today's webinar topic is micro frontends using EXT.js. Thank you for taking time out and being here today. Hope you're all staying safe and taking required COVID precautions. Let me get started with a brief introduction about our company. So we are a walking tree. We are specialized and pioneers in building web and mobile applications, end-to-end applications for the cross-platform applications. Okay, and we also help customers in doing some system integration. We do help customers in migrating the legacy or old application architecture to the newer architecture. And today's webinar topic is also somewhat related to that. Apart from that, we do help managing digital content for our customers. And we do also provide certain auxiliary services like DevOps, quality assurance, UX design. Okay, and we are one of the early adopters of Sencha. We are the partners, Sencha implementation partner as well as training partner for Sencha from last 8 years. And we do have some products like Engage Well. This helps people to do objective-oriented performance measurement in their organizations. And we are in collaboration with e-government foundation in building the urban governance platform. Okay, this is briefly about Walking Tree. Then I'll quickly move on to speaker's introduction. So my name is Suman, and I'm heading engineering division in Walking Tree. I have close to 14 years of experience related to building, putting architecture together, putting the design together, and guiding team in the agile methodologies. I have my colleague with me. He's funny, and he's a senior technical lead, and he has close to 10 years of experience in building applications, web applications using EXT.js and Angular. So let's get on to agenda. This is a brief agenda. So we talk about the evolution of application architecture. This means how the application architectures are evolved from the time some kind of end user applications are developed. So how the architectures are evolved, we cover that aspect of it. And that sets the context for the need of the micro frontend architecture. Then we cover what is micro frontend architecture and why do we need a micro frontend architecture. Then we talk about web components. Web components are important building blocks for the micro frontend. So we will be talking about web components and giving a brief demo of the web components. Then we cover briefly about why EXT.js is an excellent choice for web components. What are all the things that you get out of box from EXT.js to build a micro frontend. Then we talk briefly about how to build micro frontends, and we back it up with a demo. So at the end of the session, we'll have a question and answer session. So in between, if you have a question, please post it in the question and answer session in the box. We will be able to address it at the appropriate time. Okay. So let's get started. So evolution of application architecture. So the application, so what is meant by application? That is an app that can be used by someone else on his own. Okay, that is called an application. Then how this app application architecture is evolved over a period of time. Okay, let's go back somewhere in 1974. Okay, maybe close to 74 onwards. Some kind of desktop application started coming in. That's where the people end customers who are in a position to use some kind of computer. Okay, so as they started using the computer, they need some kind of application to be running there, and they can do certain tasks on their own using those applications. Okay, so these were the applications. The applications are pure desktop-based applications. That means you need to install your application in the same device, and it will work there itself. Okay. The communication to the external world is almost zero, negligible, and anything that you want to talk, the communication is through floppies or other disks that are available at that point of time. Okay, so here all the front end, back end, database, all of them are combined, and they were into the single application. Okay, then what happened after that? After 1974, maybe some change started coming in from 1990 onwards. Okay, so this is the time some kind of internet, the connectivity in Europe and America, some kind of connectivity started, protocols are coming in, some kind of connectivity enabled. So that's where some kind of server applications were there, and there are desktop applications still there. So what happens is that once you deploy the application in the server, you will get some link to download. So when you click on some link or something, so you'll download some exe, or maybe you get an exe, physically distribute the exe to all the people, and then that exe will be installed. That exe will be talking to the servers here. So server has all the work, server has all the computation, and at the server only those exes gets generated. Those exes are distributed to the clients and physically, and those clients exes talk to the server, and the communication happens there. Okay, so this is how some of the applications that were built around 1990s. Okay, then a change came around the 2000, maybe early 2000 or late 1990s. So the application started, the browser started coming in. So Internet Explorer came, Netscape Navigator came. So as the browser started coming in, so the need of installing a separate application into your desktop started coming down. So you can directly click on some link, it will open up, and that browser is going to talk to the backend. It's going to make a request to the backend, and then backend in turn talks to the database here. Okay, and still from 2002 onwards as well, like maybe early 2000s as well, servers are playing a predominant role in terms of they do serve the front end as well. That means application is packaged into the WAR file or some related file in other technology. Then these servers are going to serve the web application. Okay, so that's how it happened. Then with the advent of technologies like EXTJS and other technologies, EXTJS created the path, and Angular and React other applications started coming in. So these applications became a single page application. So front end and back end is kind of separated here, maybe sometime in 2010 like that. Okay, or maybe 2008 onwards. Okay, then what happened? That after that we have from 2014 onwards, this microservice architecture came into picture. What happened? These big applications, these applications of that were built in early 2000 or started building from 2000. These became big applications. They are functionally rich. They have a lot of functionality. Millions of people are using the functionality, and there is a lot of dependency on the functionality. But the challenge with for the companies, the technology companies, is that they are not able to reach out to the customers quite often and quite early. Okay, so any small change, release cycles are longer, 6 months release cycle, 7 months release cycle. Finally, application goes to production. Sometimes the change fail percentage is very high. That means the change may fail. You took 6 months to develop something, but when we went to production, it may fail anytime. And if something fails in production, maybe a reason could be because of a small change somewhere it was done, but entire application may go down. So there was no graceful degradation. So these challenges are there. So that's where, how do we solve these kind of challenges? That's where from 2014 onwards, people started talking about microservices architecture. Okay, in between, service-oriented architecture came into a play, where those monolithic applications are wrapped with the services, so that can be exposed to the external devices. It can be a front end or some other back end application. But microservices took over, and the idea is that, can I make entire backend application into smaller independent modules so that they can do their job effectively and clearly? Okay, and the development team, or maybe one module, will be owned by a small set of team, and they do take care of the complete DevOps. They take care of the development, they'll take care of the operations as well. So that's the idea behind the microservices. Okay, so as these microservices are evolved, people can consume these services through any device. It could be a single page application, it can be a mobile app. So that's how this microservice architecture evolved. Okay. So from 2014 or 15, it's gone. Like by 2018, some change started coming in. Okay. The people started asking a question that as technologies like EXTJS provide a lot of functionality, front end became strong. Earlier, back end used to take care of everything. Now front end became equally strong. That means a lot of computation happening in the front end as well. Okay, so that means only 50% of the application became microservices or microservice related architecture, but still 50% of applications are monolithic. Okay, that's the time where people started talking about micro front ends. Okay. So I'll be covering a simple example application here, and most of you are familiar with this application. Anyone of us who is using e-commerce application, they know. They have as a simple product, the product display talks about what are all the different features of this product, and there is a cart, a basket, and there is a related products. That means if people are buying these products, they would like to buy some related products. Okay, so this is a common feature across most of the e-commerce applications that you see. Okay, so this is a front-end application. We take this as an example and we create a case and we talk about what happens, what was the case with a monolithic application, and what happens till microservices. Then this creates a case for the micro front end. Okay, we use this example throughout the application, throughout the webinar. Okay, so if you see the monolithic application, you have a single code base here. You have some web pages for product separate web page, basket separate web page, for Inspire separate web page, separate backend, separate classes for the backend, and some config files. So, but still is a monolithic application. It is a single code base, and everything is kind of packaged into a single application, and maybe a simple WAR file. Okay. So the technologies are prominent like Servlet, JSP, ASP.NET, HTML, CSS there. So the biggest challenge with these problem with the monolithic application is that it's a single code base, and any small change you make, you have to do entire regression testing. Release cycles will become longer and tightly coupled. A small change you make, you have to make changes in multiple places. Okay, so that's the challenge with the monolithic application. Okay. Now, what happens? The next step is that, let's say, separating a front end and back end. Okay. So earlier in the monolithic application, you have a front end sitting in the same code base, and everything is served from the server only. Now, a front end and back end is separated, and this is kind of accelerated from the technologies like EXTJS. Okay. So front end, you'll have a single page app, and the back end, you have a REST services or a SOAP services, some layer that is built. Okay, both front end and back end separated, and front end is developed through single page app UI frameworks. Then back end is developed through Java, .NET, or Node.js. Okay. So that's again a challenge is that the problem is kind of segregated. So UI is a monolithic here, and a backend is a monolithic here. So maybe a 50% problem is solved, not completely. Because backend code is separate. If you are changing, you have to test entire backend, and if you are changing a front end, you have to test the entire front end. Okay. Again, release cycles are significantly lower compared to monolithic application, but longer in terms of customer expectations. Then comes the microservice architecture. So people started taking out, okay, this small component, okay, let me build a separate microservice for product, and let me build a separate microservice for basket, and let me build a separate microservice for the Inspire. Okay, so that's how the microservice came into a picture, and a lot of products now either they're in the path of migration to microservices, they're already migrated to microservice. Okay, so we have certain pros here. So business logic is segregated, and you can deploy on your own separately. Each module can be deployed separately, and each backend functionality can be taken care through a different technology. That means, example that if you think that Inspire, that means automatically putting recommendations can be done nicely and effectively through Python, you can do it. Right? You don't need to stick to the base technology. Okay, this product is in Java, so I have to do every functionality in Java only. Okay, that is a kind of solved, but primarily in the back end only, not in the front end. Okay, but the challenge here is that front end is still monolith, and you have to use a single front end technology, even though in a single big enterprise application, different modules has a capability that if you do in a different technology, still you don't have a choice. You have to live with a single technology. And again, for even a single UI change, you have to do a complete regression testing, and release cycles are longer. And this became a further challenge because the front end became very strong. That means it is equally holding equal power compared to the back end. So 50% of the application logic is lying in the front end as well. Okay, so that's where the need. Okay, how do we solve these challenges? Okay, so this is where this question led to the invention of, or coining the idea of, micro frontends. Okay, so how do we bring in the concepts of microservice into the front end UI technology, because backend and front end are altogether different. Okay, so backend talks about REST communication, but front end does not have that kind of communication. You have a different communication needs in the front end. Okay, so with that, micro front end concept is there, but it is based on the microservice architecture, but purely and clearly designed specifically for the front ends. Okay, so with this is the case for micro front end. Then from here, Funny will take care. He will talk about why and what is micro front end architecture, and then he'll cover the rest of the topics as well. Thank you, Funny. Go ahead.
Thanks a lot, Suman. Hello, everyone. This is Funny here. So, thanks for joining the session today. From here, I'll take you through understanding why we need a microservices architecture, something similar to, why we need a micro front-end architecture, which is something similar to microservices. And we'll try to build a sample web. We'll see what is the building block of this microservice and build sample applications or sample components with a plain JavaScript as well as EXTJS, and then conclude with the demo. So to start with, so as Suman already explained, evolution of architecture came till the microservices, where the functional modules, a code or application is divided into multiple functional modules, and each one has their own a way to build, and they have a choice to choose their own technology and deploy as and when needed, and revert back when it is needed. So similarly, let's understand what is needed in the UI, which can be addressed by a microservices architecture, so that the similar kind of features come into the UI. So as we know, the industry today, like, no more a UI developer and a backend developer. Industry is heading towards a full stack developer, where even the teams are divided into functional teams, where a team is taking care of their own, the functional specific UI as well as backend. So as Suman said again, the UI is becoming more and more complicated and more important. Like similar to the backend, all the functionality, 50% of the functional or a business logic is going into the UI. So UI is becoming heavy. So the simpler architecture like microservices is needed here. So I have just tried to list out a couple of things which are why we need a microservice kind of architecture. Is like need of microservices kind of architecture, so that each module can be developed and integrated seamlessly in the runtime with the other modules of the bigger application. And deployment should also be independent. We should be able to deploy a new version of a specific module in our bigger application and revert back anything. And polyglot frontend, like again, with the microservices architecture, backend has got an option to choose the technology based on the that functional module needs. They're able to choose the specific technology and build the functional module in that specific technology. So similar kind of option should be available for the UI as well. So today we have multiple UI frameworks available in the market, like Sencha, EXTJS, Angular, they act and all. So each module might have a different needs where we had to choose a different technology. But with the current architecture available with the microservices, UI is still a monolith. So throughout the application, we should be using only one. That should not be a case anymore. And isolated module code. So as with the microservices architecture, as we have a backend code isolated to the module or a functional module, similar case should be with the UI as well, where the given functional UI module can be developed independently and maintained and run or deployed independently, and as well as integrated with the huge application as well. Let's look into the how it is going to work. Let's say the previous module that Suman has presented, the microservices architecture. From this, there was a single app container, single page app container in which the all the modules has got their own UI. Now they should be separated out, and there should not be a UI single UI container in which all the modules would be lying. So along with the, if you see a product basket and inspire module, which we have as Suman said, the example from the example application, it has a multiple modules like product, a basket, and an inspire module, which is about related products. So as we have a database and the backend as an independent independent code, UI should also be independent. As we see now, the modules became vertical where they have their own backend database server, backend server, as well as a UI running in independently. But this would not completely fulfill our need because product alone cannot do anything, or a basket cannot do alone anything. There should be a higher level container where all these modules or independent applications, UI applications, are sitting in a single container, which together becomes a e-commerce application in our case. And these modules should be talking to each other. I mean, seamlessly communicating with each other so that completely it becomes a end-to-end e-commerce application. So here is the magic. Who helps us to do it here? Do with this to establish the communication between these two, these multiple components, and we are here saying that each module can choose their own technology. Like product can be built in Angular, basket can be built in, let's say, Sencha or React or Inspire in a Vue. That's a three different applications, three different modules built in three different technologies, but they three of them should be sitting in a single HTML document and should not be sharing any runtime variables or the data available in the document. So here comes the latest feature of W3 standards is a web component. So web component helps us to establish this communication and render these modules in the single document as a independent component, and still not sharing any of the global, the data or the document resources, HTML resources to be. Let's see how it works. As I said, web component, it helps to build their own component using their own choice of the technology, and it helps us to build the component or the complete application, the module application with putting into a simple HTML, custom HTML tag, example, a basket. So whatever the basket we see here in this small screenshot that I try to add, the basket is a simple HTML, custom HTML tag, which would bring in all the basket module functionality into this whole bigger page, and it will be able to communicate with the other components like product or the related products components through the tag names. That is a basket here, you can call it as a task name, tag name, and attributes and events. Through attributes and events, as a public contract, this web component helps to build a communication between the modules. As we know, when there are multiple modules, there should be a contract. In case of microservices, this HTTP protocol and the API documentation that we publish, WSDL, would act as a contract between the multiple services to get and push the data. So similarly, this attributes and events here would become a public API or a contract to communicate between the multiple web components. So if you see here, this I try to put a little diagram where the tractor and the small tractor icons towards the left, you can see segregated into a product web component, which would show the list of, the tractors and the list of tractors. And the basket component, which is above, which will handle the after adding it to a cart, like calculating the price and total price and all. Buy component is all about fetching the price from the product component and showing it and allowing the user to add to the cart. Related products is another component which you see on the right side with the selected product related item showing in the list. So each one of this component does their own job, and still they need a data from the other component to do its own job. So this is how the communication helps, like product talks to basket, buy as well as related products using attributes or the events. Going forward, we'll see an example with attributes and events as well. Moving into the next one, so when we're talking about web components have certain specifications that helps us to build all these features. First one is a custom element specification, which lays out the foundation for the design and using the new type of DOM elements. New type of DOM elements here is a custom elements that we are going to create. So this custom element specification helps you to define a new HTML tag with all the HTML fragments and the related JavaScript business logic embedded inside a custom tag, which can be understood by the document and rendered. And the next important specification is the shadow DOM specification, which helps you to encapsulate the style and markup, meaning the HTML fragments that you're going to define for your new web component, and as well as the styles. Definitely for HTML, we need a style to show it in a proper way. So, and we are talking that multiple web components would be sharing the same document. So if there is a conflict in the styles or conflict in the styles of those elements or the classes, then there would be mismatch between the UI. So this shadow DOM helps us to encapsulate the new web component style within itself so that it cannot be shared with the others. More of, in a single word, it can be said encapsulated or scoped styles. HTML template element specification, which is again to declare the fragments, the new fragments that we are developing with the new custom element or web component, and it helps to make this new element is not used until the page is loaded, and it gets affected once its related JavaScript is loaded. ES module specification, the script tag with a module attribute, which helps to load the module TypeScript or the JavaScript code as a module and in a performant way, so that your component would become modular. It works as intended. Here we'll see a sample web component. To build a sample web component, the custom element specifications like the hooks that we can talk about. So when you're trying to define a new custom component, these are the methods that are helpful, and they act as a synchronous hooks. Like constructor is one method or a hook which can help to instantiate your web component, where you can write your instantiation code, like using establishing some connections or maybe utilizing in instantiating the other objects. Connected callback is a callback asynchronous method again, which would be called once the element is added to the document, your custom tag. Let's say basket is the custom tag that we have created with our new web component. Once this basket tag is added to the document, the connected callback function or a method of your web component would be called, where from there you'll start initiating the DOM related functionalities like rendering additional HTML fragments to the under this custom tag, or adding styles or any other initialization like establishing IndexedDB connection or anything. Disconnected callback is another hook, again an asynchronous hook, which would be called once your custom element tag, in our case it is a basket tag. If the basket tag is removed from the HTML document by any other JavaScript fragment or JavaScript snippet, then the disconnected callback will be called. It's like a final statement which would help you to write a cleanup code when your component is getting detached from the document. For example, like if you establish an IndexedDB connection or using anything, then you should be able to write the cleanup code there. And the other one is an attribute changed callback. As you said, as we discussed, the communication will happen through attributes and events. So the new attribute tag that we are going to create new tag that we are going to create that can have attributes. So once there is a change in the value of those attributes, like let's say the buy component can push some, if buy component want to push some data to the basket component, it can change the value of the attributes of this basket component, so that this attribute change callback would be called with the new value, where you can write your business logic to do the needful from there. Adopted callback is again another synchronous hook, which would be called when your HTML tag is moved from one document to another document. We'll see, this is the sample code that I tried to show you here, a sample web component where it is a ES6 class, export class toggle button, which is extending HTML element, and I have here constructor and the observer attributes. The observer attributes are here the attributes that we want to listen, or our component, web component has to listen, should be listed out here. Only those attributes which are listed here would fire or call this attribute changed callback. Now let's get into the code and see how we can do. So before getting into doing this web component in EXTJS, let's try to understand how to build a simple web component using JavaScript, which has the capability to read the input from the attribute and change its look and feel on user in. Let's say what I've tried to put an example here is like the button, which has got a toggle functionality, where on toggle it would change the color of the button background color from yellow to blue and all. And update button is an external component, external button, like a simple HTML button, which would change the value of a text attribute of a new web component. Our web component would listen to that change and update its own text. Give me a second, I'll share my screen and take you through the code. Entire screen, okay. So here you can see a team basket code that I've written. I have, folder in which is a simple web application, simple Webpack application that I have created with a very simple Webpack config with the Babel and transform classes plugins. This transform classes and custom elements plugin, Babel plugin, helps you to compile your code, the custom element code, and make it understandable to the browser. So if I take in app.js, let's try to build, here I have multiple examples. Let me take this and here, and okay, before that I'll go into the toggle button. If you see, first thing is define this toggle button with the required functionality, and then register this toggle button with the tag name as toggle-button, and the class that should be used to render this custom element should be registered here. Now this helps, this custom elements define would help the document to understand that there is a custom element and it has to render. Now if you see in this code, I have written constructor and then called super, just to make sure that HTML element capabilities are inherited here, and then observed attributes. As I said again, here I'm trying to read two attributes like text and pressed. So whenever there is a change in the value of these two attributes, I would like to, our component would like to listen to those data changes and then do the needful. And connected callback, as I mentioned, when the element is ready and rendered, added to the document, this method would be called, where we are reading the attributes of text and pressed, and then to this web component, I'm meaning under toggle button, toggle button inner HTML, we are adding a new div with the classes button and a toggle button as a two classes, and whatever the text that is passed in the text attribute is passed here. And then adding a listener, click listener, on click of this toggle button, toggle button component, web component, it should call this toggle button. And then based on the pressed value that is read, we are calling a set pressed button, which would change the classes. So set text is again, I'm querying the div element under this toggle button and then changing the inner HTML with whatever the data is received in the text attribute. Toggle button is which will be clicked which will be called on a click on the div. It is changing the set attribute, changing the value of the pressed attribute of the same toggle web component. So that in turn it fires this attribute change callback, where if you see, as we are listening for two attributes, name, old value, and new value would be received as an arguments to this function or the method. So here, if the name is pressed, we are calling the set pressed, otherwise set text, which would carry out their own their operations. Like set pressed would do what it would do. It would add replace the toggle button class with the toggle button pressed, and vice versa based on the value of the pressed, which is received from the new value. Let's see how it works. Here, the toggle button component, I am going into app.js, and I've imported custom elements is one import. Web component custom element is something that we have to import, which would again give that custom element classes availability to our code. Imported toggle button, and in the index.html, I had another code as well. Let me comment it out. In the index.html, I had a div list tag and one old button tag added. Here I'm using the list tag, list div, and adding a toggle button with the text my button and pressed as false. And again, for the old button, we are listening a click event, and in the click event, we are querying this text toggle, toggle button web component with the given specific ID, and changing the attribute text attribute value to updated text, and then adding it +1 so that index changes. And the same button I have added once again with the pressed true. The initial button is with pressed false, and the next button again with the pressed true, just to see that the attribute is attribute is respected when it is rendering, as well as that if there are two different instances of the same component, or two instances of the same component in the same document, both of them would work separately, independently. Code is compiled. Let me go here and refresh the application. Sorry, just give me a second. Toggle button. Okay, it looks like it's fine. Okay. So here we can see the my button and press button was initially in the blue pressed color. So if I go and inspect this component, here if you see, this is the toggle button, the new component web component that we have added with the custom tag name toggle button, and the ID and the text which internally rendered the div. And then the next button is a simple button which will update or change the value of this toggle button text. And then the pressed button, toggle button with the text as pressed button and pressed true, so its value is changed and color is changed here. Now clicking on this update text, as we've listened to this event and updating the attributes, here you can see the text attribute of the toggle button is changed. Once that is changed, attribute changed callback is listened, and it is updating the internal div text. And similarly, once you click on this button, you can see the pressed attribute value is changing to true false, which internally the attribute changed handler is being called, and it is changing the class value. Now, other important thing that we have to notice is here I have added BTN and toggle button or toggle button press classes, where these classes are defined or declared in the SCSS style.css class. Now, this button class has got margin, width, and especially border color as this almost not completely black, but slightly black. Now, if we have another web component in the same document, and if that web component is also using a button class, then you would see that component is also having the same border color. This is where the shadow DOM feature comes into play, where you can scope your styles, web component styles to your web component itself, so that even though the same class is used or declared in the document, that will not impact our or your web component. To that, I've created similar component, same component in fact, but just using a shadow root. Only the difference that you can see here is attach shadow DOM with a mode open, and instead of adding the inner HTML to the this, I'm adding inner HTML to the shadow root, and the rest of things are same. And the way we are querying is a little bit different. Instead of this dot query selector, we have to query under the shadow root. And rest of the things are same. And in the custom elements define, I'm declaring this web components tag as toggle button shadow. Now let's enable this in the app.js. Like I've commented out toggle button and added toggle button shadow. Let's say I'll do this as well, so that we can together see both of them together, or not disturbing, or the button class values are not changed. Let me go here. Yes, we don't have anything. Now let me compile the code. Now we should be able to see the shadow buttons as well as the normal ext buttons. Sorry, normal web component toggle buttons. Now if I refresh the screen, I could see this is the my button. If you see here, for the shadow component, we have overridden the btn class with a border as black. btn class with a border as black. Now, and if you look at the HTML of this shadow component, you see the under the toggle button shadow HTML tag, the shadow root document has created, right? Which will have the styles that we have given and the div elements that we have added as an inner HTML. So this shadow root is kind of a document created for the component itself, web component itself, so that the elements or the CSS classes that we define, styles that we define, are scoped. The rest of the functionality is same like this, and you can see this button. If you even inspect, this button is different and the actual button is different. I mean, btn classes are different. This is the black. It's not overriding. If you observe, it's not overriding. Right? It is the only class that is added to the specific element, as this is in this root document. So this is about a shadow. We have looked at how to build a normal with the plain JavaScript web component, as well as the shadow root, what is the use of shadow root, and how to use build that. Now let's see ext.js. Before getting into ext.js, so why is the ext.js excellent choice? Again, as we all know, why ext.js is a better or the best UI framework available on the market, because it has 140 plus pre-built UI components that are fully supported and designed to work together throughout lifetime of the application. And it has got the ext.js framework itself has got a cross-browser support, where it works with all the browsers, all named browsers. And there is a complete ecosystem tools to support this ecosystem is available, like Architect, Humor, Inspect, TXT Build, Sencha Command, Sencha Test to run to build your test cases, and lot more. And it also has got a cross-platform support, like mobile, tablet, browser, and different browsers. And with all this, an additional benefit like the professional support, the team, Sencha team is available to support us if we are stuck anywhere. And all these features or the great things are available or supported within the web components with a new version called ext web components, with all the capabilities that we have with ext.js. So with this, the ext web components or ext.js becomes the choice to build the web components or the individual modules with micro frontends with the EXTJS. As we know, any other framework today doesn't have that capability. So in a bigger applications or enterprise applications, we need rich UI components which are available in EXTJS. And now with this EXT web components, it becomes a lot easier to add the EXT capability to your existing application without rewriting your complete application. So EXT web components has got additional benefit, like it's not, you don't need to build a complete new EXT web component. All the components that are available in the EXT classic or a modern toolkit are exposed as a web components by themselves, so that you can, in your web application, you can just, let's say if you just want a grid, you don't need to build all this a new web component and all. You just need to, you can just go ahead and add the EXT grid tag into your application, the way we have added a toggle button or toggle shadow, and provide the required data as attributes, and then the grid should work. That's how the EXT web components are doing a great job in micro frontend world. Now let's see how to build a micro frontend in EXTJS with the example that we have seen, the application. Let me share my screen and demonstrate. If you see, this was the application that we have been showing in from the initial slides as well. This application or a sample application I have taken from the microfrontends.org. This is where the idea of micro frontend is found out. So if you see this application, this is the products module where the red part is supposed to build in on an Angular or a different technology, where it has got the products, and once the product is selected, the data is pushed to buy as well as related products, so that if you observe, when I change the product, the buy value is getting changed and the related products gets changed. And once you click on buy, this 58 euros item would get added to the basket, and how many items you add, the number of basket items would increase. Now this basket doesn't have any functionality as such, but let's try now with EXTJS grid capability. For a sample, let's try to add a behavior to this basket, so that clicking on this basket would show a grid panel, cart panel, where it has the product name and unit price, as well as the number of count or the quantity of the specific product is added to the cart, and the total price for a given product with the quantity. Right? Now let's get into the code, and I hope you're able to see my screen. Yeah, you're able to see my screen. So here, the complete code that you're seeing here, this is the application that is rendered there. I've pulled out the same code, and in the same code, I've added one more vertical called team basket, which is rendering or changing that team bucket, baskets capability with EXTJS. I'll quickly take you through this. This is the index.html, forget about this. And here, if you see, the simple page has got all the 4 applications or functional modules JS files loaded. That's all. And the JS file, their own JS file has got their own functionality or logic to add their elements to the complete page. I'll take you through just red page. If you see, this is again a component which they have created, where it has got products and the different functions to render, handle events and all. And this is rendering page, independent page. Inside this, they are adding this custom web components like blue basket or blue buy and green repos. Blue buy is the button that we are seeing here, the blue buy button, and blue basket was earlier built with not plain JavaScript, but now we have replaced this blue basket with our EXTJS component. And green repos is something that related product that we see. Now let's see what did we do to add a communication. I mean, let's look at the communication between the buy and the product. This is the communication, right? Let's see how this blue button is buy button is communicating. So once the product is changed, the product would push change the value of SKU attribute of this buy button, which would internally get the data of the prices from the price declared above. And it would actually fire on click of this button, it is calling an add cart. which is internally firing a custom event with blue column, basket column changed with the data that is uh, data of the product that is captured. So this event, somebody has to listen and do the rest of the job. In this case, the existing blue button component, I have removed their blue button web component, blue basket web component. I have created a new blue basket, which we are going to build an ext.js, which will listen to this event and do rest of the job. Now getting into this blue basket, let's say this is the basket web component that I have created, where here if you see, let me take you through the package.json as well, where what are the dependencies that we have to add is definitely web components and web JS, which are apart from ext.js, but still they are needed to build an independent or this one. But Sencha has got its own web component JS in the Sencha package. Apart from that, I have added very specific to Sencha. I have added these two, the packages. One is Sencha ext modern runtime, which would give all the, here again, I'm using a modern toolkit. So modern runtime would give all the ext core library capabilities, and modern web components would have the list of components, all the modern components in web component manner. So now these two are available in the index.html. Right now, I'm going to add this modern engine enterprise.js, and I've chosen material theme. So material CSS to the index.html, but this is not really need to be added in the index.html. But right now, I have added it to make it very simple. But in the webpack config, we can write our code to combine or compile the ext library as well as our code together and build a simple bundle out of it. So adding these two, and as I have Sencha ext web components, modern web components, all I need here, the components I need here is a button component. I can remove one button component and a grid. Grid internally uses column, so we need a column. And then the panel. So in the panel, I'm preparing a floating panel. Inside the floating panel, I added a grid, which would open up on click of a button on the ext button or the basket button. Now let's see in the connected callback. I mean, this is a my view class. Instead, I could make it as basket as well. Basket class, which extends the ext HTML, extends HTML element, where I'm adding an ext button with just an ext button, which would initially show text basket colon 0 items, and the ID I've given as basket button, so that I can refer it with a get the component with a basket button. And then I've added an ext panel, which is hide and mask tab true, title as cart, close action as hide, draggable, hidden model, and maximum height is 1000 pixels. And inside this panel, I have added ext grid, right, which is using the back store, which I've created here, an empty store with ID, name, price, quantity, and the total price, which are the 5 columns that we are going to show in the grid. So this backstore is configured here, and we have added the 4 columns like name and the unit price and the quantity and the total price of that particular product that we are seeing. And in the connected callback, after adding this inner HTML, we are adding a listeners, where I would like to listen to the basket button, where on the basket button tap listener, I would go and show the panel. And how do I query the panel? Is this dot component select query selector of ext panel, and the element would have a CMP attribute or a property which would give the ext component instance. On that I can call show. And then listening, add event listener, adding one more event listener to the window, like which is published by the blue buy button, like blue underscore basket underscore changed, which we would listen to that event and then call the refresh method. Refresh method would accept the detail or fetch the detail object from the event, and then get the grid store and find the record. If the store has already this product, then change the quantity, price, and total price. If there is no record with that product, I mean, the first time we are adding the product to the cart, then inserting the data here and updating the count. And then on updating the count, we are updating the text as well. to show the number of items added to the cart, not products. Given product can be added multiple times as well. So that is considered there. Let's see how it works. Now let me comment out these two and include this basket. And in the index.html, I've added these two, and then here this is an independent component we are building separately. So there should be somebody to give the data, right? Give the data to my basket button so that it renders or shows all this functionality. So for that, what I've done is I've added two buttons with a blue by blue by one, blue by and blue by one, which is the first product and second product to text. Like clicking on blue by would add a product with the price 50, tractor one, and blue by one, the second one would add a tractor two button to it. I mean, tractor two data to the cart. So that now our component should be able to listen to this data and show the grid internal. Code is compiled. Let's get into the code here. The sample again with the same, but with this one. As you know, what I said in this code, I have removed in the blue team blue, I have removed this blue bucket and added our basket bundle app from our team basket build app bundle.js, so that now the blue basket available is our own component. So it should render here. Sorry, change the name, right? So here I have changed the class name to basket, and then in the custom elements define I've been using my view, so it is not. So that's the important thing. Custom element should be defined or registered. Otherwise, the browser would not identify your custom component or web component. Now here is the button. Let me close this. Now if you see the products, we can see here the related products are changing and the price is changing. Now if I click on this buy 58, item added 1, 2, item added 2. Now if I select a different product and click on add, the items became 3. Now one product I've added twice, and the 54 one I added once. Let's say I'll add twice, and then 66 voila, I added only one. Now there are 6 items in the basket, but 3 products. First one with 2, and then 54 unit price is 3, and 66 1. But the total price of the line price is 66, 162, and 116. I've directly taken you through this one, but generally if we do this, I mean, first we test it here, where like the dummy products here, these are the dummy components which are adding to the items, and render this card. This is the sample application where we are testing or launching our application independently. Once this is working, then we would add our application or this specific just blue basket component to the whole bigger application, where our application works internally, I mean independently, as well as in the bigger application as a single component. With this, we have seen how to build a web component, which is eventually micro frontend with ext.js. Now, here you have docs.sencha.com, where you have ext web components. Here you can go through the documentation and see how to use in each component. All the components are available and very good. Sencha is good in documentation, where you can see a lot of documents, example codes available for each component. Let's take an example of grid. So here every component is shown with an example. Like here, a simple example, if you can see, the web component is built with this grid, existing grid and it is registered with a mygrid. And index.html will have just a mygrid. And directly you should be able to use directly the ext grid as well, as we are using an index.html as our custom tag. Even ext grid, this is the tag that you should be using if you just don't want to build any additional functionality on top of your ext grid component. You just want to use the grid as it is, the way we have used in our custom web component, basket web component. Similarly, this one can be taken and added to our this one as well. Let me show you that as well. Maybe move it to index.html. Let me add it here and then store. But here we should have some data. As we have this enterprise modern engine and everything.
We're running a little bit short on time, and I would like to wrap things up so that we don't automatically get kicked off of Bright Talk, unfortunately. So go ahead and finish what you're doing, but we do need to wrap up.
Okay, so yeah, maybe we have looked at the demo, and if the references, like again, as I said, the example that I've taken from microfrontends.org and enhanced that framework, I mean, that sample application. Maybe if the code that we are trying to, that I have demonstrated now, if required, I can share it in my GitHub. And ext web components and docs I have been referring to. And now it's a question and answers time. Well, can you share the tractors code? Yes, I'll be able to share that in a GitHub. Maybe, I don't know, you can, let me create a GitHub now. Oh.
We can go ahead and follow up on the questions in a follow-up blog post. So we will keep things open now for people to continue entering their questions, and any questions that are asked, we will answer them in our blog. So just stay tuned there. I linked the blog in an announcement to the audience, so you can go there, subscribe, and we'll send you an update when that blog post is available. Great. Well, I really appreciate you, Suman and Fani, for joining us and giving this this wonderful demo. I feel like we all learned a lot here today, and I think that there's a lot to continue in further presentations in the future. So I look forward to working with you both again.
Okay. Maybe as David said, maybe in the blog, I'll be able to share the GitHub repository as well for this, and we'll try to answer all the questions in the blog.
Wonderful. Great. Well, thank you so much. So our presentation will automatically cut off here in about 50 seconds, but I'll leave things open for the audience to continue submitting their questions that we, again, will answer in a blog post. So in the meantime, I will say thank you so much to the Walking Tree folks, and we look forward to everyone joining us next time.
Thank you. Thank you, everyone, for joining.